Hello everybody, this is Tiziano of XWorks, and today we're going to unbox the Intel Aero ready-to-fly drone. The ready-to-fly kit is created for us developers that want to integrate the Intel Aero board with our autopilot as any other companion PC. But rather than buying the board and building up your drone for your testing, this kit comes in handy so we can start developing almost out of the box. Here at XWorks, we put our hands on the Intel Aero drone because we're evaluating the Intel Aero board for our projects, and we thought it would be great for you guys to stick with us and follow our steps during this mini series. Today, we're gonna open the box and we're gonna have a sneak peek of what's under the hood. Then we're gonna install all the software and we're gonna test all the video devices. Then we're gonna connect with the ground control station. Now, the kit usually comes with Linux Yocto pre-installed and is ready to fly and to connect with your ground control station through the access point that he creates. So in order to install Ubuntu, I had to wipe the disk clean, but I won't go through that process because it's too boring for the sake of the demonstration. If you want, I put a link to a video tutorial in the description below. Check it out if you have trouble following me. Most of the developing that we're gonna cover in this mini series can be applied to any other companion PC, especially running Ubuntu, so stay tuned. Now, there is a lot to cover in this video and I want to cut this introduction short, and I think it's time to get started with the next tutorial. And here is what we got. The Intel Aero platform for UAVs. So let's open this up. Okay. And here it came with the ready-to-fly drone. See, it has a nice tall-looking camera, an HD camera, and the real sense with an HD daylight camera, and the two infrared cameras and the infrared light. This is the push button for powering it up. And that's the classical XT60. And here we have a spectrum, not really a fan of spectrum, but it's okay. So you stand this GPS antenna up, and the system is ready to go. Great, so we have two Wi-Fi antennas here. That's great. So this is the drone, and here we should have the propeller. Yeah, they are unique style, stupid proof. Black goes with black, white goes with white. Okay, you just spin them. Okay, great. Then you push it for unlocking. Nice. Now what we got here is the spectrum. This is a pretty cheap radio transmitter, so this should become already programmed. It's for a ready-to-fly kit, it's okay. Now, if you want to power up this system, what we need to do is you have to slide a battery in this compartment here. Now, this compartment is not very big, especially because there is this column in the front. This is made for a 4500 4S battery, but I will probably gonna fly with this 5200 milliamp battery. So I will need to take this column off, but for the sake of this demonstration, there's no problem, so I can slide it in. See, it's not perfectly balanced, something like here, not bad. I will probably even leave it here. Let's see how it works. I'll plug it in, press this button, and the system boots up. And if you want to shut it down, I keep this button pressed. The LED starts blinking and it shuts down. Now, before start developing, you probably need to buy a few other extra components that don't come with the kit. One is the USB adapter. This is nice for plugging multiple USB devices into the board. It plugs here in the USB 3. Now it's ready for a dongle for your mouse and a keyboard. Then you need also to plug this system to a monitor. And for that, you need an adapter. You need a micro HDMI to HDMI adapter that plugs here. Here we go. Now this system is ready for you to start developing. You can plug it to your monitor, or your keyboard and mouse, and it's ready to go. Now, if you're a developer like me and you spend long hours keeping this system on your desk, you probably need a power supply. If you don't have a professional one, then all you need to have is a 2 amp 12 volts power supply, like this one. For this one, I created this adapter that goes from the jack to the XT60. And so you can keep your system running on your desk for long hours. The first thing that everyone would do is open this thing up. Here we have Pixel style connector. This panel keeps them nice and pushed inside, so you shouldn't experience any disconnection during the flight. So we have the telemetry port that is free, so you can connect even a data link here. Radio in, this goes to the receiver. Here it goes. This is the compass and the GPS that connect to the GPS here. And then we have the power supply. The power goes to this box. This is the distribution board. The distribution board connects with the battery and distributes the power to the motors and powers up the Intel board. Okay, let's open this up. Okay, so I pop it completely open. This is the Intel Aero board. Under this heatsink, there's the 64-bit Atom processor that is a 2.56 gigahertz processor, if I'm not mistaken. We also have the RAM access memory, and here on the top we also have the solid-state disk. On the side, here on the side, there is a slot for another SD card. This is not provided in this kit, while here we have the USB 3 port, and here underneath the board we have the mini HDMI output. This connector, this is the power and communication connector. So in a normal companion PC configuration, this connects with a power supply and also with the TX and RX of your autopilot. It connects with this distribution board here. This connector here on the side, this is the main connector for any expansions, and it connects with a flat cable to the top here where we have all the connectors for the power and the GPS and data link and radio receiver. The flight controller is under this board, so we're not gonna pop it open because I don't wanna mess it up. So I'll close it and I'm gonna boot it up and start setting up our Ubuntu. For this tutorial, we're gonna follow the wiki on the Meta Intel Aero GitHub page. Here we are after the installation. We connect with the Wi-Fi and we open the terminal. Now we add the Intel Aero repository and the key to our sources. Then we update. And also we can upgrade. Now we make sure that we have everything for streaming video, installing GStreamer, libGStreamer, and the RTSP server. Then we install GStreamer VA API, the plugins base, and the plugins good. We also install the plugins bed, the libav, the ffmpeg, and the v4all utils. Finally, we make sure we have pip. Now we install mavlink with sudo pip install py mavlink. Now it's time to set up the whole Aero system with sudo apt-get install Aero system. And we reboot. Now we update the BIOS with sudo aero BIOS update, and we reboot. Now we check the version with sudo aero get version. Next step is being sure that the FPGA is programmed with the last release. So we use gem to program the FPGA. That'll take a little while, so be patient. Now we can select which of our firmware we want to load in the autopilot, and we can choose between Autopilot and PX4 stack. We can select them into the folder etc RFC. Here you just load the firmware using rfc update.sh. In my case, I will stick with PX4 stack. Mind that if you change the firmware, you have to recalibrate the whole system. Now it's time to set up the Intel RealSense camera. We go ahead and we install git, libusb, package config, libgtk3, and cmake. After that, we clone the Intel RealSense libRealSense library. Now we create a directory build that exists in my case. So we go in the build directory, we create a cmake with dbuild example true and dbuild graphical example true, and then we make it and install it. Now we check out if the camera streaming daemon is running with systemctl status csd. Now we list all the devices in the video star, and we have all the 13 video. Now we list all the v4L2 devices, and we make sure that we have the Intel RealSense 11, 12, and 13 video output. Now we make sure that we are talking to the autopilot through the TCP port 5760. Now we enumerate all the CPP devices, and here it is the RealSense with all this data and settings and parameters. Now let's test the Intel RealSense with this tutorial. As you see, it's my hand that it's waving. And also we're gonna capture the videos from the cameras. So here is this demo where I have the HD camera, the 2 infrared cameras, and the depth map. We also want to check that the port 8554 is listening with netstat. Now we got to set up the Mablink router, modifying the file qgc-conf. Here you set up mode as normal and the address of your ground control station. You can also put the host name if you want. Now we reboot the service and we should be online. Here's the system in ground control. The video can be set up in the options here. The quality is better than it looks. It's just my grabber. To get the video, you just go in the options and you set the RTSP URL here. We can also connect with Mission Planner through the UDP port 14550. And the video can be read through VLC using the RTSP address. So, the setup was pretty easy, and you can follow my steps even in this page over here. This is the Intel GitHub page. I also invite you guys to subscribe to our channel and to check out our website, XWorksHD.com. Follow even us on LinkedIn. There is a lot coming out this year, so stay tuned. In the next video, we're gonna create our first autonomous mission and we're gonna see how the drone flies. But for now, I thank you for watching and I'll see you next time.